Good morning. All right. So today again is just going to be a review day. So we're going to go through the practice test and give you a chance to ask any questions you might have. Don't forget that the test will be posted at 11:59 p.m. tonight. Okay, so I'll do that so that it's not confusing about 12 a.m. versus 12 p.m. Okay, so 11:59 p.m. It'll be due by 11:59 p.m. on Wednesday night. So you've got 2 full days to get that done. But again, once you actually start the test, you have 2 hours to actually complete it. Okay, so just make sure you're finding yourself, a 2-hour window. It may not take you the full 2 hours. Okay, but just make sure that you blocked yourself out enough time that you can actually sit down in a quiet place and actually take the test. Again, you're going to do it the same way you did the Respondus tutorial. So make sure that if you haven't already done that, I would advise you to do it so that you know exactly what to expect on this test. Make sure you've got the browser downloaded. You know what the steps are to actually get in there and get started on the test, that kind of thing, okay, because it's going to be the same way. You'll complete it on notebook paper. You'll exit the browser. You'll use your phone or tablet to scan it, or if you have a scanner, you can use a scanner, and then you'll save it as a PDF and then upload it, okay, to the link that's provided. Okay, any questions, though, about the test? Very similar. Okay, so you can expect it to be the same length, same types of questions, that kind of thing. Okay, so if you can do the questions on the practice test, you should be prepared for the actual test. Any other questions? That's right. So I'll have a link to Desmos in the actual browser. So once you go in and start the test, the first link will be to the test. It'll be a PDF, and then there'll be a second link that actually takes you to Desmos if you want to use Desmos on the test. And yes, we still have class on Wednesday. Yeah, and we'll actually start chapter 2 on Wednesday. Yeah, and thank you for reminding me. So remember I told you that we've got some catch up to do. And so I have started recording videos for chapter 2. And so on Wednesday, we'll kind of discuss what things are we going to cover in class, what things will I expect you to go back and watch the video for. And I'll get the videos posted for that so that we can try to get back on track in terms of our homework and test and that kind of thing, just to make sure we can finish everything up by the end of the semester. Desmos really isn't that bad. It's actually more user friendly, I think, than a graphing calculator is. But I would say before you start the test, obviously, just go to desmos.com and actually try it out. Play with how to put equations in there, see what they look like, that kind of thing. Maybe go through the practice test using Desmos if you think you're going to use it on the actual test. But yeah, it's pretty user friendly. But if you ever have questions about it, just send me a message, email me, and I'll be happy to explain anything in there. That's right. If you have a graphing calculator, you can use one. The only ones that aren't allowed are like the TI-89 and TI-92, just because those have computer algebra systems built in. But anything like a TI-83, TI-84, those are perfectly fine. Yeah, and so just make sure, right, when you're scanning your environment for the test, just make sure you've got your calculator on your workspace, right, so I can see that you're using it. Any other questions? Yeah, so the main thing is just, try to find yourself a space away from as much noise as possible, right? If there's background noise and stuff, right, I understand there's not much we can do about that in the times we're in. But, try to keep other people at least out of the room that you're going to be in. And definitely don't be talking to other people during the test. That's the main thing. Because I just want to make sure, that you're as focused as you can be, and the work on there is your work, right? That's the main thing. Any other questions? If you have anything on it that's math related, then yes, I would prefer that you cover it up. The question was about a whiteboard, if you have one like in the background or something. Yeah, is when you're scanning your environment, if you show it to me so that I can see that there is no math on it, then you wouldn't have to cover it up. But if you do have any math on there, then obviously I would want it covered during the test. Any other questions? All right. If you think of anything else, just ask, right? And feel free to email me, after class if you need to, before you actually start your test, if you think of anything else that you want to ask me. Okay. All right. So let's go ahead and start the review here. So again, this is posted in the practice test section of Blackboard. Full solutions are posted there also. So feel free, to go back and look at my solutions. I'm going to do the work pretty much the same way here that I would have on my solutions anyway. And if there's any discrepancies, right, then I'll let you know about those. But in general, they should be pretty similar. All right, so if we take a look at number one here, we want to factor the expression completely. And it tells us we're going to begin by factoring out the lowest power of each common factor. All right, so I give you a little hint there. So what are we going to factor out this time? Good. X to the negative 3 halves, right? Because that's the lowest power that we have this time is the negative 3 halves. We're going to have, hang on 1 second. There we go. X to the negative 3 halves times, and now we just have to figure out what's left over if we factor out x to the negative 3 halves. Okay, so remember the way I did this before was I took each term and I divided out the x to the negative 3 halves. If we do that for the first term, x to the negative 3 halves divided by x to the negative 3 halves, what's that going to give us? Just one, right? Because in this case, the x to the negative 3 halves and the x to the negative 3 halves, they completely cancel each other out, and we're just left with a 1 in this case, right? So this first term here becomes a 1. Any questions about how I got that? Okay. All right, so now we want to do the same thing with the next term. So I've got 2x to the negative 1 half. I'm going to divide out the x to the negative 3 halves. All right, so how are we going to do that? Subtract exponents, good, right? So in this case, we have a negative 1 half, and we're subtracting a negative 3 halves. I'm going to come over here and do that work just so we can see where we get this. Sorry, negative 1 half minus negative 3 halves. Right, so when we subtract that negative 3 halves, what is that going to become? It's addition, right? And so this is negative 1 half plus 3 halves. And when we add that together now, that's going to give us 2 over 2, and that does simplify to 1. Good. All right, so that tells us now what the exponent is going to be. So what's our overall answer going to be when we divide these two things then? 2x, right? Because we have the 2 in the numerator, we're going to keep that, and then we're going to have an x to the first power, right? Because again, that subtraction of exponents tells us what the new exponent is going to be. So that becomes 2x to the first. So now I have a plus 2x up here. Any questions about how I got that one? All right, now let's look at the last terms. Now we have x to the 1 half over, and we're dividing out the x to the negative 3 halves. So same thing, we're going to subtract exponents again. This time we have a positive 1 half minus a negative 3 halves. Again, when we subtract that negative, it becomes addition. So 1/2 plus 3/2. And so what's that going to give us? Good, 4/2. And what does 4/2 simplify to? Just 2. Perfect. And so what's our answer going to be when we divide x to the 1/2 by x to the negative 3/2? Good. That gives us our exponent, so that becomes x squared. So now up here, we're going to have plus x squared. All right, so again, first step, find the smallest of all of your exponents and pull that out, which means you're going to divide each term by that smallest exponent. When you do that, remember we're subtracting exponents, okay? And when you subtract a negative, it actually becomes addition. That's how we get all of those terms. Any questions on that first step? Okay, now don't forget, we always want to look at what's left over in parentheses and see if we can factor it any further. Now, if you want to, we can rearrange these terms because I know a lot of people like to have the x squared first. So if I rewrite this as x squared plus 2x plus 1, can we factor that any further? Yeah, right. So what are the factors of x squared plus 2x plus 1 going to be? Good, right? So they're both going to be x plus 1. So we have an x plus 1 times an x plus 1. Or if you want to put those together, then that's going to give us x to the negative 3/2 times x plus 1 squared. So this right here would be our final answer now. Any questions on that one? If you were to stop, are you asking right there, Haley, if I had stopped at that line? Okay, if you stop at that line, then you're going to get partial credit, right, for factoring out the common factor, but you're not going to get the full credit because it says to factor completely. Okay, so just make sure, always take a look at what's left in those parentheses and see if you factor it any further. Okay. Yeah, there is partial credit, right? So I think the way I've got it broken down, and you can see this on my solutions, I think it's like 10 points for that first step, and then the other 6 points comes from the fully factoring that trinomial. So you would probably lose some points, obviously, for not having that final step, but you'd get like 10 points for the first step there. Any other questions there? All right, number 2. So now we want to factor this expression completely. So 3x to the third minus x squared minus 12x plus 4. All right, so how are we going to have to do this one? It's grouping. Good, right? So we're going to have to group because we have 4 terms, no common factors this time. So I'm going to group my first 2 terms together, group my second 2 terms together, put some parentheses here, put some parentheses here, and just a reminder that we're adding those 2 things together, not multiplying, right? All right, so now if we look at our first group, what's our common factor going to be for that group? X squared. Good. So if I factor out x squared, what's going to be left over from that first group? 3x. And we need the minus 1, right? Because I'm factoring out an x squared from 3x cubed, that gives us 3x. Factor out an x squared from a negative x squared, that's going to give us a negative 1. Just always remember that if I were to redistribute that x squared, I need to get what I started with, so that's why we need the minus 1 there. All right, now, what about the negative 12x plus 4? What would my common factor be there? Negative 4, good. So in this case, right, we could have gone with negative 4 or positive 4, but keep in mind that we want to try to match up whatever we have in this set of parentheses here. So we need to factor out the negative 4 so that we get a positive 3x and a negative 1 once we factor out. So now we have the exact same thing in both sets of parentheses here. So what's our next step going to be? Okay, so now we know that we have a common factor of 3x minus 1, right? So I can bring out that common factor. I have 3x minus 1. And then what's going to be left over if I bring out the 3x minus 1? The x squared minus 4. Perfect. That's why we need that same thing in both sets of parentheses there, so it becomes a common factor. We bring it to the front, and then we just bring down whatever's left over, in this case, the x squared minus 4. Any questions up to that point? Okay. Now, can we factor this any further? Yes, right? Because in this case, x squared minus 4 is a difference of squares. So how are we going to factor the x squared minus 4? X plus 2 and x minus 2. Good, right? Because we need an x and an x to give us the x squared. We need a 2 and a 2 to give us the 4. And because we need the middle terms to cancel out, one's going to be positive, one's going to be negative. Again, you would always look at all of your terms, make sure there's no more common factors. 3x minus 1, x plus 2, x minus 2. Nothing else we can do to factor that. And so this right here would be our final answer now. Any questions on that one? Absolutely, Ruby. So yeah, the order of these factors does not matter, right? So if you do x plus 2, x minus 2, 3x minus 1, that's exactly the same thing because that multiplication is commutative, right? You can move those factors around if you want to. Any other questions there? All right. Number 3. Okay, so now we want to simplify this expression, and then we're going to state the domain in interval notation. Right. Now, the first thing I notice here is that I've got a compound fraction, right? I've got a fraction in the denominator of another fraction. So what could we do in this case if I want to get rid of that fraction within a fraction? Good. All we really have to do here is just multiply by the square root of x to cancel out that denominator in the bottom, right? I'm going to multiply down here by square root of x. Now, if I do that, what else do I have to do? Multiply the numerator by the same thing, right? So I'm going to come up here, I'm going to multiply numerator by square root of x. And just keep in mind here, we're distributing that square root of x to everything in the numerator and everything in the denominator, right? So we have to distribute it here. So what's that going to give us for the numerator if we do that? Good. 2 square root of x plus x, right? Because 2 times the square root of x would give us 2 square root of x. When we multiply the square root of x times the square root of x, that should just give us an x now. So there's our numerator. Now let's look at the denominator. Okay, same thing, I'm going to distribute. So I'm going to distribute it to the 3 over square root of x and to the negative 1. So what would that give us if we do that? 3 minus the square root of x. Because in the first part, right, it's just going to cancel out the square root of x in the denominator, which is what we were trying to do. That's where we get the 3. And then negative 1 times square root of x gives us a negative square root of x. Any questions on that part? Okay, now I'm fine if you stop right there. If you really want to rationalize the denominator, you can multiply by the conjugate 3 plus square root of x on top and bottom. I'm not going to take off points if you don't do that, though, right? The main thing I want to see here is, can you get rid of the compound fraction? Okay, so I'm okay if you leave the square roots in the denominator. Now, the second piece of this is stating the domain. So, what do we know about the domain of this expression now? Okay, so we have a square root, right? And we know we can't have negatives inside the square root. So in this case, x must be greater than 0. Now, why is it just greater than and not greater than or equal to? Okay, so we can't have a 0 in the denominator. And I go back to my original expression right down here. If I were to put a 0 in there, I'd have 3 over 0, and I can't have that. Okay, so it has nothing to do with the simplified expression. It's all about that original expression. If I put a 0 in there, I'd have a 0 in the denominator. Because this other one, right, if I put a 0 there, I'm fine, because that's 3 minus 0. I just have 3 in the denominator. It goes back to the original expression, can't have 0 in the denominator. That's why it's x is greater than 0 instead of greater than or equal to. All right. Now, do we have any other restrictions on our domain this time? Okay, so x can't be equal to 9. Now, how do we get that? Okay, so good. So that would give us a 3 minus 3, which would be 0 in the denominator. We know we can't have 0 in the denominator, so the work for that would look like this. 3 minus the square root of x cannot be equal to 0, right? So this is what I would want to see in terms of finding the domain now. So we take our denominator from our simplified expression, we set it not equal to 0. Now, if we were to solve that for x, what would you do first? Okay, so if we add the square root of x, that's going to give us plus square root of x on both sides. So now we have 3 cannot be equal to the square root of x. And then what? Square both sides. Good. Right, so I'm going to square the 3. Square that square root. We know the square root of x squared should just give us x. And what's 3 squared? Good. That's where we get x cannot be equal to 9 now. So again, that's what I would be looking for in terms of work for this one, right? Take the denominator, set it not equal to 0, and then isolate your x, get x by itself. Now, at that point, we need to put everything in interval notation, right? So we've got that x has to be greater than 0 and x cannot be equal to 9. So if I put that together in interval notation, what would my interval notation look like? Okay, so from 0 to 9, and then from 9 to infinity. Right, and I want to make sure we have correct brackets and parentheses here. So would the 0 get a parentheses or a bracket? It's going to be parentheses, right? So we have a parentheses on the 0 because we just want to be greater than 0, not greater than or equal to. The 9, same thing. I don't want to include 9 in my answer, right? So it needs to be a parentheses there. And then for the other one now, from 9 to infinity, same thing. I don't want to include my 9. And then infinity always gets a parenthesis, right? So then our simplified expression would be right up here. That's the first part of our question. And then the domain would be right here. So those are the two things I'd be looking for on this one. Okay, now again, I give partial credit, right? So let's say, for instance, that you had greater than or equal to 0 instead of greater than 0. You're going to lose like a point or two, right? Because you don't have the correct brackets or parentheses there. But if everything else is right, you're still going to get the other 16 points on this problem. Okay, so just keep in mind, show me as much work as you can. Take your time, right? But if you make a little careless error here or there, right, it's not going to kill you. You'll just lose a point or two, okay, for those careless errors. Any questions on that one now? All right. Number 4. So we want to solve this by completing the square. Okay, so pay attention to the directions, right? Because if you solve it a different way, you're not going to get full credit. Right? I want to see it by completing the square here. All right, so what's our first step going to be to complete the square? Move the 11, right? So I need to add 11 to both sides, move it to the other side. So that's going to give us x squared minus 6x. I'm going to leave myself some space here. That's going to be equal to 11. All right, now once I've moved that c value to the other side, what's my next step going to be? Good. So this is where we're going to do our formula, b divided by 2 squared. Now, what's our b value this time? -6, right? So we're going to have -6 divided by 2 squared. What's -6 divided by 2? -3. And if we square -3, what do we get? +9. Good. All right, so now what am I going to do at that point? Add the 9 to both sides. Good. Right, so we're going to put our +9 here. That means we also need to come over here and add 9 to the other side also. All right, now that we've got that, now what can we do? Factor the left. Good. What's the factor going to look like for the left-hand side here? Good. It's going to become x minus 3 squared. Because remember, with completing the square, you're always going to get a perfect square trinomial. And then you can always just look back at this step here right before you squared. That'll tell you what that factor is going to look like. Okay, so x minus 3 because it was a negative 3. And then we just square that. Now, what about the right-hand side? Simplify that. So that's going to give us 20, right? All right. So then the next step is going to be to do what? Take the square root of both sides, right? So I'm going to square root this, square root over here. That's going to cancel out my square. So we're going to have x minus 3. And then what are we going to have on the right-hand side? Plus or minus. Good. Don't forget that piece. Square root of 20. Now, before I go on, is there any way that I could simplify the square root of 20? It is going to be 2 square root of 5, right? Because this right here, if I break it down, I can say that's the same thing as the square root of 4 times 5. And then if I bring out the square root of 4, that gives me a 2. And so now I'm going to have plus or minus 2 square root of 5 on the right-hand side. Okay. And so then our last step to get x by itself would be to do what? Good. Add the 3. So we're going to have x equals, and the order here really doesn't matter. I typically put my 3 first and then plus or minus 2 square root of 5. If you were to put the plus or minus 2 square root of 5 and then plus 3, that's perfectly fine also. Any questions on that one? If you left it as square root of 20, kind of like the last one, right, that would be one of those things where you didn't quite simplify it all the way and you'd probably lose a point or two, right? But it's not going to, I mean, if everything else is correct, right, you're still going to get the majority of the points. But you need to see it simplified to get full credit there. You cannot combine the 3 and the 2 because that 2 is being multiplied by the square root of 5. And so now the 3 and the 2 square root of 5 are not like terms. So they cannot be combined. Okay. Any other questions there? I don't want a decimal, right? Because that would be an approximation. You'd have to round it off. So I only want exact values. I would actually prefer square root of 20, right, to 2 square root of, or to the decimal value in that case. Okay, so just, either if you don't know how to simplify square root of 20, just leave it that way. But again, to get full credit, I need to see 2 square root of 5 in that one. But unless I tell you to round something, just assume I want exact values. And putting it in the calculator, you'd have to round it off. Any other questions there? All right, number 5. Right, so this is the big problem here. So we want to solve the nonlinear inequality and express the solution in interval notation. Okay, and it says to graph the solution set, which we're going to use a number line to figure out our solutions anyway, right? So we'll have that graph. All right, so if we want to solve this inequality here, what's the first thing we're going to want to do? move the 1, right? Okay, so we got to turn it into we're going to combine all of our fractions eventually, right? So the first thing, though, let's go ahead and move the 1 to the other side. Then we'll figure out what the fraction needs to be so we can combine everything. So that's going to give us 3 over x minus 1 minus 4 over x, and then minus 1 greater than or equal to 0. And I kind of spaced these out because we know we're going to have to find a common denominator. So I just left myself some space to multiply here if I need to. Anytime you have a nonlinear inequality, first thing you want to do, move everything to one side. All right, now, if I want to combine all of these, what would my common denominator be this time? Okay, we need the x and the x minus 1, right? Because remember, in this case, the 4 over x and the 3 over x minus 1, we need both pieces here. So we need x times x minus 1. That means that I'm going to multiply the first fraction by what? X, right? So I'm going to multiply numerator and denominator by x. Now the 4 over x, I need to multiply by what then? The x minus 1, good. Times x minus 1. And I have to do the same thing in numerator and denominator. And then for the 1, we're going to have to do what? Both pieces, good. So I need to multiply by x times x minus 1, and then do the same thing down here. Because again, you could think of this as 1 over 1, right? And that way we know we're multiplying the top by x times x minus 1 and the bottom denominator by x times x minus 1. All right, so now let's figure out what we've actually got here. So if I multiply that first one, what's that going to give us in the numerator? 3x. So I've got a 3x up top. And then I'm going to keep my denominator factored, right? So x times x minus 1. Minus. Now, here I want to distribute the 4. And so what's that going to give us in the numerator of the second fraction? 4x minus 4. Good. So 4x minus 4. Again, that's going to be over x times x minus 1. Minus. And same thing, I'm going to distribute the x this time. And so what would that give us for the last fraction? X squared minus x. Good. Over, again, x times x minus 1. You always want to keep that denominator factored. Any questions up to that point? All right, now I need to combine all of these fractions. Now keep in mind here, I'm subtracting, which means that this minus is going to get distributed to both of those terms, and this minus is going to get distributed to both of those terms when we subtract. So if I were to do that now, what am I going to get from my numerator? Okay, so I agree with the plus 4. What's going to happen to our x terms here? They're all going to cancel, right? And so really, all I'm left with is that plus 4 and what else? A negative x squared, right? So I have my negative x squared and a positive 4 over x times x minus 1. And because 3x minus 4x would be negative x, but then I'm subtracting a negative x at the end, which means I'm adding it. So all those x terms just cancel out. And then when I distribute the negative to the negative 4, that gives me a positive 4. Distribute the negative to the x squared, that gives me a negative x squared. That's how I get that numerator now. Any questions about that? Yeah, so I'm looking here. I've got a 3x, I've got a negative 4x, and then I've got a negative x. And so I know that's going to become positive. Well, if I do 3x minus 4x, that's a negative x. And then minus a negative x becomes plus x. So those x terms all cancel out. Then it's just a matter of looking at what's left. Well, I've got a minus a negative 4. So that's where the plus 4 comes from. And then I've got this minus x squared. That's where the negative x squared comes from. The main thing there is just be careful. Make sure you're distributing that minus to everything in the numerators when you do it. And so that cancels out all the x terms and switches the signs of the negative 4 and the positive x squared. That's how we get negative x squared and positive 4. Any other questions up to that point? All right, what's our next step going to be? Factor. Good. So how are we going to factor negative x squared plus 4? Good. Negative x plus 2 and positive x plus 2. It's really a difference of squares, right? So if you wanted to rearrange your terms and write this as 4 minus x squared instead, then it's just 2 plus x and 2 minus x, okay, which is the same thing that we've got there, right? Because the 2's are both positive, and then one of the x's is negative, one of the x's is positive. So it helps you to factor, right, by switching the order around. Go ahead and do that. Greater than or equal to 0. All right, now that we've got it factored, now what are we going to do? Okay, we've got to get our interval notation, right? So how are we going to find our intervals this time? Okay, so set the denominator equal to 0, or in other words, set each of those factors equal to 0. But we're also going to set what equal to 0? Okay, so that's the x, right? That's one of the factors in the denominator. Okay, but what else do we have to set equal to 0 here? The numerator factors also, right? So basically, anytime you end up with something rational like this, you're going to set every single factor equal to 0. So I'm going to take my negative x plus 2, and set it equal to 0. My x plus 2, set it equal to 0. X is going to equal 0, and the x minus 1 equals 0. Okay? So that's the whole point, right? We've got to get all the factors so we can set each of the factors equal to 0 now. Now, remember, all this is going to give us is what we call the critical numbers so that we can create our number line and figure out what the intervals are. So what's that first factor going to give us if we solve it? X equals 2, right? Because I can just add x to both sides. So we'll have 2 equals x. What about our second factor? You can subtract the 2 and get negative 2. Good. And then x equals 0 is already solved, right? Nothing we can do there. And then the last factor is going to give us what? Positive 1. Good. All right, so now we have all of our critical numbers. So I'm going to go ahead and draw my number line now. And I'm going to put each of those values on my number line, right? Start from the smallest and then work your way up. So -2 is the smallest. The next one would be 0. Next would be 1. And then finally the 2. All right, now once we've created that number line, what do we need to do next? Okay, good, right? If you want to do the chart, right, if that helps you to organize everything, go ahead and do that. This time, we've actually got 5 different intervals, -infinity to -2. And we've got -2 to 0, 0 to 1, 1 to 2, and 2 to infinity. And then down the side, remember, that's where we're going to put our factors. So -x plus 2 is our first factor. X plus 2 would be next. X minus 1. And then finally, the entire thing together, right? So -x plus 2 times x plus 2 over x times x minus 1. All right, now for the sake of time, right, because I know we're getting low here, we want to choose a value in each interval and we're going to substitute it in to figure out where this thing's positive and negative. So I'm going to go with -3 in this first interval down here. So I'm substituting in a -3 into each one of my factors to see does it come out positive or negative. If I plug in a -3 into -x plus 2, is that going to be positive or negative? So be careful. A -3 is a +3 plus 2, which actually gives us a positive for that first one. Just keep in mind it's a double negative there that actually turns into a positive. Okay. What about -3 plus 2? That one's going to be negative. If I just plug in a -3 for x, that's going to be negative. And then if I do a -3 minus 1, that's going to come out negative. Now, overall, remember, we're going to look at how many negative signs do we have. Do we have an even or an odd number of negatives this time? It's an odd number, so overall, this should be what? Negative. So that tells me everything in the interval from -infinity to -2 is going to be negative. Now, just so I can get to the actual intervals here, if you continue this, the next one's going to be positive, negative, positive, and negative. Okay, so again, that's just testing points like -1 here. You do 1/2 in that interval. This could be 1.5, 1.5, right, and then 3 up here. And you can see my table, right, and how I got those values, right, if you want to see that on the actual test, on the solutions. Now, once we have that, do we want positives or negatives this time? We want positives because I go back to here and I say I want this to be greater than or equal to 0. That tells me I want my positive intervals. So I look back at my number line. I've got a positive interval here and a positive interval there. So what are those intervals going to look like then? Okay, so from -2 to 0 is the first interval. Then we need our union, and then we're going to go from 1 to 2. Now, last piece is we got to get brackets and parentheses right. In this case, the -2 and the +2 came from the numerator, and we wanted this to be greater than or equal to 0. So these two values here actually make the fraction equal 0. They're going to be included. However, the 0 and the 1, if I plug those in, that's going to give me a 0 in the denominator, and that would be undefined. And so my 0 and 1, I cannot include in my solution. And so this right here would be my final answer. Now, again, if you did all the work right up to that point and you got your brackets or parentheses messed up, okay, you're only going to lose a point or two for any bracket or parenthesis that's wrong. Okay, so just take your time though, see if you can get those right. But if everything else is right here, you're still going to get most of the points on this problem. Okay. Okay, so I know other people have places to go. I'll hang out for a couple more minutes. If you do have any questions about anything, there's only one more question, and it's a linear equation one, right? Finding like a parallel or perpendicular line. Okay, so just make sure you take a look at that one on my solutions in the practice test. Otherwise, have a great afternoon. Don't forget the test will open at midnight tonight, and you've got until Wednesday at 11:59 p.m. to complete that. Okay, let me know if you got any questions though, and I will see you on Wednesday.